I want to welcome everyone and thank you for attending Houghton International's webcast on fire-resistant hydraulic fluids for the food processing industry. My name is Tony Noblet, and I am the Market Development Manager for the Fluid Power product line at Houghton International. I've been with Houghton for over 32 years and have worked in various areas of the organization, including fluid power research and development, technical services, product management, and marketing. The purpose of today's webinar is to discuss how food processing plants can improve their safety and cost efficiency by using fire-resistant hydraulic fluids. The function of a fire-resistant hydraulic fluid is to protect the most important assets of your facility, the first being the people working in the plant. Next is the product, the food being manufactured. The fire-resistant hydraulic fluid needs to be approved for incidental food contact in the event of a hydraulic line leak. Fire-resistant hydraulic fluids protect the plant from the danger of accidental fires. A huge investment has been made in the machinery used to operate the plant. These issues lead to the bottom line that both personnel and the plant will be significantly safer and more productive. Is your food processing facility in danger? Absolutely. Your plant is in serious risk right now if you're using a petroleum-based hydraulic fluid. Wherever heat or flame are in close proximity to the hydraulic equipment, a ruptured hydraulic line or fitting can eject a combustible spray of hydraulic oil onto an ignition source, causing a fire. In 1991, the Imperial Foods processing plant in Hamlet, North Carolina, caught fire and burned to the ground. The fire was caused by a faulty modification to a hydraulic line, which leaked a spray of flammable hydraulic oil onto a hot fryer, causing flames to explode throughout the area. There were over 90 people on the shift in the plant at that time, and out of those, 25 lost their lives, and an additional 54 were injured. And even though this was an extreme disaster, this is certainly not an isolated incident. More recently, in the first 8 months of 2013 alone, there have been over 32 fires experienced in food processing plants in North America, many of which may have been prevented if the manufacturer was using fire-resistant hydraulic fluid. Dangers, mistakes, risks, and tragedies like these need not be repeated. The Imperial Foods disaster was completely preventable. In my opinion, this corporate tragedy would not have occurred if a fire-resistant hydraulic fluid was being used at the time of the incident. Most substances can be made to burn and support combustion under certain conditions. Most hydraulic fluids are mineral oil-based and are considered flammable. Fire-resistant hydraulic fluids resist ignition and prevent flames from propagating from the source of ignition. Fire-resistant fluid science uses the most up-to-date, cutting-edge technology to make fluids safer and more efficient. The fluid power industry recognized the need for a safer work environment through the use of approved fire-resistant hydraulic fluids. Factory Mutual tests and approves products and classifies them as being fire-resistant. Factory Mutual is an insurance underwriter. They set the standards for fire resistance by developing methods to test materials that claim to be fire resistant, including hydraulic fluids. These fluids go through rigorous testing processes, and only if they pass all of the tests performed will Factory Mutual certify them as being truly fire resistant. Factory Mutual is involved in all aspects of fire safety, including facility inspection to ensure the plant is fully compliant with fire safety regulations. Using a Factory Mutual approved fire-resistant hydraulic fluid can significantly reduce insurance premiums for the food processing manufacturer. Savings of 50% or more have been realized by customers who have made the switch. There are standards that food processing plants face that industrial manufacturers are not required to meet. In food processing facilities, products need to be USDA, NSF approved. This ensures that hydraulic fluids contain the ingredients that are recognized as safe and suitable for use in the processing industry. Fire resistance is a huge challenge in areas where heat is involved in the process to manufacture the product. In the event of a hydraulic line leak, the fluid needs to be approved for incidental food contact. The NSF works in conjunction with the USDA to ensure that hydraulic fluids entering the food processing facility are tested and approved as safe for incidental food contact. In other words, they are H1 approved. Working with the USDA and NSF has allowed specialized hydraulic fluid technology to operate in food processing facilities that meet the criteria of being both food grade and safe for incidental food contact, with the additional benefit of being fire resistant. Fire resistant hydraulic fluids are only good as their performance. High quality formulated fire resistant hydraulic fluids perform equally as well as oils. All hydraulic fluids must have the qualities that they lubricate, resist oxidation, dissipate heat, have low foam tendency, protect against corrosion, and have good viscosity temperature properties. Fire-resistant hydraulic fluids do offer a significant advantage over oil. In order to operate in a food processing facility where there is a potential for food contact, the product must be H1 approved regardless of type classification. One of the major advantages over oil-based fluids is that they have a high flash point, which is a major component of being classified as fire resistant. These fire-resistant hydraulic fluids are also bio-based, which makes them more environmentally friendly and a renewable resource. Also, as mentioned previously, from the financial standpoint of the manufacturer, these products can significantly reduce insurance premiums the manufacturer pays as a result of a reduced risk factor. Now let's talk about some specific type hydraulic fluids that are fire resistant. Water glycol type fire resistant hydraulic fluids that are specially formulated for the food processing industry contain a polyglycol thickener. This gives the product its viscosity. They are water-based, which is the basis for the fire-resistant component, as well as containing propylene glycol, which gives the product its low-temperature properties. Special additives are incorporated into the product for lubrication, as well as liquid and vapor phase corrosion prevention. All of the components formulated into the product meet Factory Mutual and USDA NSF rigorous standards. The anhydrous products, or otherwise known as non-water content products for the food industry, are composed mainly of vegetable oil, which makes them bio-based material and a green renewable resource. Carefully selected additives enhance the product's viscosity, anti-wear, and lubrication properties. These products also contain inhibitors to prevent rust, corrosion, and oxidation. Just as with water glycol products, all of the components formulated in the anhydrous fluids meet factory mutual and USDA NSF requirements. Fire-resistant hydraulic fluids are a safety-proven technology that has been in operation since 1954, with over 200 million gallons in operation across North America alone. To keep the manufacturing industry running safely, at the present time, approximately 20 million gallons of fire-resistant hydraulic fluids are shipped annually throughout the U.S., Canada, and Mexico. Fire-resistant hydraulic fluids are used in various industries, including food processing manufacturing, steel-making processes, foundry operation, and with the U.S. military, just to name a few. Fire-resistant hydraulic fluids have advantages and disadvantages based on their chemistry and the specific need of the industry manufacturer. The water glycol fluids are recognized by original equipment manufacturers as a result of their proven success in operation at major food processing facilities. The anhydrous vegetable oil-based product formulation is green, being environmentally friendly. In manufacturing facilities, the conversion to anhydrous products from mineral oil-based fluids is fairly simple, since mineral oils are generally compatible with vegetable oils. In summary, the advantage and benefits of fire-resistant hydraulic fluids for the food processing industry include improved plant safety because they reduce the risk of system failures, high quality, low risk formulations that meet good to excellent performance standards, reduced insurance premiums due to factory mutual approvals, and H1 approved, making them safe for incidental food contact. Houghton International is the global leader in supplying superior, cutting-edge technology fire-resistant hydraulic fluids to the food processing industry. We have shipped over 200 million gallons of fire-resistant hydraulic fluid throughout North America alone. Houghton International offers the most extensive line of fire-resistant hydraulic fluids, from water glycols to vegetable oil-based products to high water content fluids to polyol-esters. All of the fire-resistant hydraulic fluids in the Houghton product line have been tested and approved by Factory Mutual. Houghton International's line of fire-resistant food-grade hydraulic fluids include How to Safe TY series, which are water glycol type, and our Cosmolubric FG46 vegetable oil-based fire-resistant fluid. Please visit our website for further details on these and other Houghton metalworking products at www.houghtonintl.com. I hope this presentation was informative and helpful, explaining the serious safety risks to your food processing facilities and the positive impact on making your plant safer and more cost-effective by switching to fire-resistant hydraulic fluids. At this time, I would be happy to respond to any questions you may have. This slide indicates the process for submitting your text questions. We have several questions here that have already been submitted during the presentation, and to start us off, here's the first one. In what types of food processing equipment do fire-resistant fluids operate? Well, mainly in the food processing industry, they operate in areas where heat is involved, say to manufacture, cook the food. This would include cookers, fryers, ovens, and even char markers. A second question is, in the slide entitled Definition of Fire-Resistant Hydraulic Fluids, what does propagation from the source of ignition mean? Well, in this case, proposition or propagation of fire means if there's hydraulic line leak and the fluid should happen to hit an ignition source, it may fire briefly at the point of contact, but it will not follow the flame back to its origin. So that's the propagation from the ignition source. We have a question, how do prices compare to mineral-based hydraulic fluids? Well, in this case, you could probably say that they are almost doubled in terms of price. So a white mineral oil may be in the area of $10, $11 a gallon, while we look at some of the fire-resistant hydraulic fluids, could be in the area from anywhere from $16 to $22 a gallon. But with that price, you ensured safety and a reduced insurance premium. Another question coming in. You mentioned that fire-resistant hydraulic fluids are used in military applications. Where specifically would the product be used? Well, in one instance, they are used by the U.S. Navy in the aircraft carriers where they are used in the catapult systems. The catapults aboard the U.S. aircraft carriers, the planes are jettisoned off the deck by using hydraulics, but the catapults by using steam, and they are retracted by using hydraulics. So in this case, the hydraulic fluid, the fire-resistant hydraulic fluid, is water glycol, and it retracts the catapult and keeps the ship safe from fire. Another question coming in, we have, what are the operating temperatures, limitations for water glycol fluids, and what type of applications would an anhydrous FR fluid be? For the water glycol type products, we like to see the operating temperatures between 90 and 120 degrees Fahrenheit. They could operate at 150 for short periods of time, but the issue with water glycol fluids is they do contain water, and the hotter you run them, the faster the water evaporates out. And when you get water evaporation, the viscosity of the product has a tendency to go up. As a follow-up, what type of application would an anhydrous FR fluid be? In some cases, the FR fluids, the anhydrous type, are used in areas where the pressure may be a little bit higher, where water glycol products aren't rated to operate in those conditions. So some pump manufacturers will recommend anhydrous fluids over water-based fluids due to some of the operating pressures. Next question that has come in: to convert existing equipment, what are the steps? Well, to convert from a oil-based system to a water glycol-based system, the most effective thing would be obviously to drain out all the product in the system, clean out the reservoir with some lint-free rags, crack some of the hydraulic lines to get out the oil. In most cases, with water glycol type fluids, it may be best to flush with a small amount of the water glycol and then drain that out and then fill the system with the fire-resistant water glycol for operation. If you're converting from a oil-based to a vegetable-based oil, that is fairly simple. Simply drain, swab out the reservoir, and crack some of the lines, and then fill the system for operation with the fire-resistant anhydrous product or the vegetable oil type. The one thing you want to be aware of is that the mineral oil contamination in the fire-resistant vegetable oil-based products needs to be 5% or less, otherwise you will compromise the fire resistance of the product. Question has come in: most of these products, must these products be stored indoors in a controlled environment? The How to Save series product, the water glycol type, does contain propylene glycol and do not have to be stored in indoor controlled environments. As for the Cosmolubric SG46, this is a vegetable oil-based product and should not be stored in areas 0 degrees Fahrenheit, minus 17 degrees Celsius. If you've ever placed some vegetable oil in your refrigerator at home, you'll notice that it becomes cloudy and streaky. This principle is the same for the vegetable oil-based fire-resistant hydraulic fluids. You can simply get the vegetable oil back to its temperature, the normal range of temperature, and it will resume its clear appearance, and there will be no performance issues. Question has come in: during conversion, are there any compatibility issues with seals and gaskets? For water glycol products, the only seal that you need to be aware of is polyurethane. Some polyurethanes are not compatible with water-based products, but with the water glycol materials, your Buna-Ns, your Vitons, neoprenes are all satisfactory. As far as the anhydrous or the vegetable oil-based products, there's one seal that you need to be aware of there also, and that is neoprene. Neoprene is not compatible with the vegetable oil-based chemistries. But once again, your standard Buna-N/nitrile type seals and your Vitons are compatible. Questions come in: if these FR products have been around since the 1950s, why do you think so many plants are still using petroleum oil? I think that question, I can answer that is probably just based on awareness. With this webinar, we are trying to make folks aware that these particular types of products are available for the food processing industry and can help and protect your plant and personnel from accidental fires, and also have an economical benefit by reducing insurance premiums. What types of vegetable oils typically exhibit fire resistance? With some of the genetic engineering that they're using on some of the seed oils, they have developed vegetable oils that have a very high flash point. And flash point is one of the major criteria from Factory Mutual as being an approved fire-resistant hydraulic fluid. So with the genetic engineering of some of the seed oils, we have increased the flash point of some of these vegetable type oils and have deemed them as being fire resistant and proven by Factory Mutual as such. Question has come in, does Houghton label their product drums to inform the customer of proper storage and usage? Absolutely. All products manufactured by Houghton International are clearly labeled for proper storage and handling of our products. Safety data sheets are also provided as documentation with every purchase. What is the normal life cycle of a fire-resistant hydraulic fluid? Well, the normal life cycle of a fire-resistant hydraulic fluid is very difficult to answer since each hydraulic unit is unique in itself. Hydraulic units run at various temperatures, various pressures. How often do they run? Are they running 7 days a week, 24 hours a day? So it's difficult to determine actually how long the product is going to last in the system. Houghton International provides our customers with analysis on the fluid samples. So we actually determine a baseline through the initial sample and samples taken thereafter. We typically recommend that samples be sampled at least once a quarter, and we offer this at no charge to our customer, and we encourage our customers to take advantage of this valuable service. Are there any other questions from the audience? We have one final question. Is there a minimum and maximum micron for filters? Houghton International's food-grade hydraulic fluids can be filtered down to actually 3 micron absolute without the fear of stripping out any of the additives formulated into the product. As far as a maximum level, what we typically recommend as best practice is to determine the component on the hydraulic unit that requires the cleanest fluid. So for example, a directional valve requires a fluid cleanliness of 18, 16, 14. We would base that, or you should base that, as the target cleanliness specification for the entire system and filter accordingly. What type of analysis should be done on the fluid? Well, depending on the fluid type, water glycols, we typically run a viscosity, a pH. We centrifuge the material for any type of oil or sediment contamination. And we also perform particle counts on the water-based materials, on the water glycols. For the anhydrous products, we go a little bit more in depth in terms of analysis. We run the viscosity, the total acid number, which is an indication of the breakdown or decomposition of the product, water content for any water contamination, and a specific gravity, which tells us if the product has been contaminated with any type of oil. And we also centrifuge the material for any sediment and also perform particle counts. Are there any other questions from the audience? Well, thank you very much, everyone, for taking the time to attend this webcast and for your interest in a safer environment. If you have any additional questions or would like additional information, please feel free to email me directly at tnoblit, that's N-O-B-L-I-T, @houghtoninternational.com.